Hello friends, welcome to Wing Gravity, and today we are going to talk about the chapter of atoms and molecules, and this is the class 9 chemistry chapter, and this is the part 3 video. So in this part 3 video we will discuss about the symbols for atoms, we will also discuss about the IUPAC. So let's dive deep into the part 3 videos concepts. So why do you think we need symbols for atoms and elements and all these kinds of things? Because, for example, if we need to write each and every element in this universe, you have to write it for a whole page. A whole page space would be just like that occupied, and that is a waste of space. And also in the representation of a molecule, you can't write like carbon 6, hydrogen 12, and so on. You can't. It occupies so much insane amount of space. It actually would occupy an entire page if you write so many molecules and compounds, reactions and all these kinds of things. And we know that as we go to higher classes and higher research kind of studies, there will be lot of reactions and the whole page would be filled with reactions. And in such cases, even writing C6H12O6 occupies this much amount of space. And imagine if you had to write it as carbon 6, hydrogen 12 and oxygen 6. That would occupy insane amount of space. And that is the reason why you need to use some kind of symbol. And in this video we will talk about how this symbol evolved as time progressed, and how it evolved and why it evolved and all these kinds of things. So basically, if we see this, Dalton, that is the person who actually proposed the Dalton's atomic theory, was the first to use some kind of symbol to represent different types of atoms. So actually if you see, this is the image that shows us what and all symbols he used for different elements. So the number of elements in those times were very small because it was not discovered that much. So as you can see, these are the main elements present in this thing. So for hydrogen, he used this kind of big circle and with a dot in the center. And for lead, he used that kind of like L symbol with a circle surrounding it and all these kinds of things. So this is the proto version of what we use today. So this was the first kind of symbols. Then actually if you see, this is a very tiresome process because you need to memorize it, and as the number of elements grows, this is not actually comfortable because you should memorize like completely unrelated diagrams with this, right? So for sulfur, you have to memorize like a crisscross with a circle enclosing it, and this is kind of weird and this is very also tough. And at the same time, it also occupies so much amount of space. See, for sulfur, this is the symbol. I can just put it as S, right? So the molecule for sulfur is S8. So for this I have to write like this. So it occupies so much insane amount of space. So that is unnecessary. And that is the reason why it again evolved into something else. So basically if we see, our kind of representation was first suggested by the Berzelius, the scientist known as Berzelius, and he suggested the usage of letters combined for symbol of an element, either one or two letters combined for the symbol of an element. And this thing was later being slightly modified today and being used. So he was the first one to propose these kinds of things, and Dalton was the first to use the symbol itself in the nature. So these two things are really important. So let's go to the next point. So this is the next point. The symbols of elements generally trace back origin to the language of Latin or English. So for example, gold actually is an English word, but we represent gold as AU, which actually is a representation of the Latin word aurum. Okay, what is it? Aurum. So from this word we have represented AU, that is for gold. So the symbols of elements nowadays, what we are using it now, actually trace back to either Latin or English. So in this case it is Latin. AU is from the Latin word aurum. And also for, if you see for example nitrogen, for nitrogen, that is an English word, and that is basically N. So basically for this nitrogen, the element, the symbol is deriving origin from English and not Latin. So for some the origin is Latin, for some it is English. So symbols of elements generally trace back origin to language of Latin or English. And these names were named with respect to the place of discovery or the name of the discoverer or some important property of it. So either this or this or this. Most of these elements are named on base of these three things or mostly. So this is very important too. So as I said, Berzelius was the first one to suggest the usage of the letters for the representation of symbols of atoms and elements. And this thing is slightly modified right now to become this wholesome rule. That is, currently elements have their first letter or first and another letter of their Latin or English name. So what does this mean? So either you have to use the first letter of the element or it is already used, and in that case we have to use the first letter combined with any other convenient letter for their Latin or English name. So for example in nitrogen we use the symbol N. Neon also is starting with N, but we can use another letter. So neon, let's see the spelling. Now I can use it Ne. Okay, so basically the first letters are same, but I can distinguish these two elements with respect to the second letter. So in the case of nitrogen there is no second letter, so I can just assume it as nitrogen. But in the second case I have E, so it is no longer nitrogen, it is neon because it has a E in it. So currently we are using the rule as either you have to use the first letter or the first letter with the another letter. So if the first letter is already used, for example the nitrogen has the symbol N, then you can't use N for neon also, because that would mean it would mean confusion, right? So for that you have to use another letter. For neon you have to use N combined with another letter. So in this case for neon we are using E, and thus we have Ne for neon. So this can be derived either from the Latin or English name. For example for lead we use plumbum, that is Pb. So this is actually the symbol from the Latin name. So why don't we use just P instead of Pb? Because P is already used for phosphorus, and thus I have to use P with another letter of the Latin name. So plumbum, this is the Latin name for lead. So I can use P and another letter. So let's take B. So this is how it works. So as there is already P existing for phosphorus, I can now use Pb. So Pb, that is for the plumbum or lead. And there is another rule that the first letter should be always a capital and second one should be a small letter. So as you can see, as I have written, like the first letter should be a capital one and the second letter should be a small letter, if there is two letters actually. So if there is only one letter, then I can just simply write it as a capital N, just like that, or capital P, just like that. So these are the rules, and this is how the things evolved as time passes on. So this is the rule actually. Currently elements have their first letter, or if they are already used, then you have to use the first letter with another letter of their Latin or English name. Then the first letter should be written as a capital letter and the second letter should be written as a small letter. So now we have completed about the symbols for atoms, and as you can see, the IUPAC is what actually, so it's like a commission or an union to approve the names and symbols for elements. So for example, if I used for gold for gold, if I used the symbol GD, and if somebody used AU, and if another person used GL, then that would create insane amount of confusion. That is not going to be good. And that is the reason why there is a commission or an union in which scientists are there to approve names and to use the standardized version globally or worldwide. So this commission approves the names and all these kinds of rules and all these kinds of things, and this is known as the International Union for Pure and Applied Chemistry, IUPAC, International Union for Pure and Applied Chemistry. So this is what is IUPAC. So thank you for watching and subscribe to my channel Win Gravita and stay tuned for the upcoming videos.